it's an incredible experience because you actually feel the vibration as the shuttle lifts towards the sky.
1, we have booster ignition and liftoff of Space Shuttle Columbia with a multitude of national and international space research experiments. 10, 9, 8, 7, we have a go for main engine start. 5, 3, 2, 1, we have booster ignition and liftoff of Space Shuttle Columbia.
On January 16, 2003, the Space Shuttle Columbia took off on a scientific mission with 7 astronauts on board.
NASA says none of the seat restraints, helmets, and spacesuits used by the doomed crew of the Space Shuttle Columbia worked well as the ship disintegrated during re-entry. All 7 astronauts were killed in the February 2003 accident. The agency is just now releasing a 400-page report that includes graphic details of the tragedy and what happened in those final moments. In it, the agency says the failure of the restraints, helmets, and suits led to lethal trauma. However, it says it's not clear if the astronauts were already dead or just unconscious from the lethal lack of cabin pressure before the blunt force of the spinning out-of-control shuttle would have killed them.
The Space Shuttle Columbia disintegrated on its way home. The tragedy killed all 7 astronauts on board, and it was the beginning of the end for the Space Shuttle program, ultimately changing how we explore space now.
We've got some breaking news. A few minutes ago, it was about 8 o'clock because we had just started at the top of this hour, the Space Shuttle Columbia was going over North Texas. You're looking at a live picture now of Mission Control. And this was the shuttle going over North Texas. At the time, it looked like a normal re-entry because the shuttle would normally light up in re-entry because of the heat of the friction of the Earth's atmosphere. But then we began to see this.
You'll notice here, it looks like you can see pieces of the shuttle coming off.
13 years ago this week, on February 1st, 2003, Space Shuttle Columbia was returning home from its 28th mission when disaster struck.
The shuttle broke apart over Texas and Louisiana as it re-entered Earth's atmosphere. All 7 crew members on board were killed.
At the press site, that announcement from the public affairs people at NASA, there's a shot of the people who are here to see the launch, or landing. In some cases, family members, we think they're gone already, and many Kennedy Space Center workers, top officials of NASA are probably among that crowd. Viewers, people who come here to, always to cheer the landing and to see the space shuttle come home. And this is the 113th mission, 111 times the space shuttle has come home with no problem, and everyone's cheered and been happy. You had Challenger back in 1986 that did not return, and now you have STS-107.
Hi guys, I'm from Group 4, and today we are going to talk about one field invention under the theme of modern space. So what is modern space? Modern space typically refers to the current era of space exploration, which includes advancement in spacecraft technology, satellite systems, space research, and related innovations. It encompasses the developments made in space exploration, astronomy, and cosmology using contemporary technologies and scientific knowledge. The term modern space itself distinguishes the current state of space exploration from historical space, involves and signifies the ongoing advancements in our understanding and utilization of outer space.
So next, what is the Space Transportation System, aka STS-107 mission? STS-107 mission, also known as the Space Shuttle Columbia disaster, was the 113th flight of NASA's Space Shuttle program. The mission began on January 16, 2003, when the Space Shuttle Columbia launched with 7 crew members on board. Unfortunately, the mission ended in tragedy when the shuttle disintegrated upon re-entry into Earth's atmosphere on February 1st, 2003. And the disaster was primarily caused by damage to the shuttle's thermal protection system during liftoff. A piece of foam insulation from the external fuel tank struck the left wing, damaging the shuttle's thermal protection tiles. This damage went undetected and during re-entry. hot gases enter the wing, leading to a structural failure. Then the Columbia disaster led to a suspension of the Space Shuttle program and a thorough review of shuttle safety, procedure and design. After that, it also highlighted the risks and challenges associated with human spaceflight, emphasizing the importance of addressing safety concerns in future missions.
Hi guys, so now we're going to talk about the problems of STS-107.
STS-107, the 113th flight of the Space Shuttle program, particularly ended in the disintegration of the Space Shuttle Columbia during re-entry on February 1st, 2018. Several critical factors and flaws during the mission led to this catastrophic event. The Columbia disaster was attributed to a closure for foam insulation from the shuttle's external fuel tank. NASA discovered flaws in the procedure of applying foam insulation. NASA's extensive testing revealed that tanks bearing some section of foam caused gas or waste. Tests post-Columbia disaster indicated that liquid hydrogen could seep into this waste. During launch, the heated gas within would lead to the detachment of large insulation pieces. Anti-test damage occurred at lift-off on January 16. A damaged pieces affected the left wing's thermal protection system component.
The damaged wing caused a heat buildup during re-entry, leading to shutter loss of control. The damaged wing gradually overheated, leading to the disintegration of the orbiter during the re-entry process. The shuttle's disintegration resulted in the tragic loss of the entire STS-107 crew and the Space Shuttle Columbia. The Columbia disaster prompted a significant reassessment of safety protocols and inspection methods within the Space Shuttle program. This catastrophic event left a lasting legacy, emphasizing the crucial need for enhanced safety measures in space exploration. In conclusion, the Columbia disaster identified critical flaws, emphasizing the importance of robust safety protocols and meticulous engineering in space exploration.
Next, we're gonna talk about solution of STS-107. I'm gonna pass it to Paco.
The new orbiter boom sensor system was utilized by the crew. 3 spacewalks were completed by the crew while they were at the station. NASA has made significant modification to the foam application procedure, but tests and maybe other procedural adjustments are still necessary before the tanks are cleared for flight. Currently, the largest challenge facing the tank problem is recertification.
According to the new regulation, during the first 135 seconds of flight, no foam fragments heavier than around half an ounce may come off the tank. NASA is currently exploring a program meant to foster private sector solution to assist International Space Station operation in low Earth orbit that is far smaller than the pieces that have consistently popped off. The goal is to enable the space agency to enter into contracts.
So moving forward, we're gonna talk about our suggestions. So Taki?
In order to prevent them from easily disintegrating in extremely hot conditions, from plastics and thermoplastics, composites are employed as effective thermal insulators. NASA should test the space shuttle without any crew members inside initially in order to learn more about how the foam functions.
NASA should minimizing the foam insulation from the bipod linking fuel tank to the forward portion of the orbiter and limiting foam insulation loss during launch. NASA engineers should modify several of the tank's external features so that the foam insulation could be sprayed on more uniformly, without voids, and could expand during launch to prevent dislodging.
That is all from us. Thank you very much for listening to our report on mounted space and its failed inventions.
Thank you. Bye.
Mantap.
Kau tolak naik atas. Shut up. Okay. Okay, on. Done.
Next, we're gonna talk about solution of STA pula. Ikut dah?
Belum.
Jangan tekan start dulu.
Okay.
Aku intro dulu.
Tolong tekan start boleh Mia? Belah kanan ni. Kau sorok sikit lah. Aku dah record lah. Kau boleh start anytime.
Next, we're gonna talk about solution of Start sekali.
Tak apa, cakap lah. Kita edit. Dah.
Hello there.
Tadi ada salah sikit, tapi tak apa. Aku dah.
Ya.
Dah sikit. And NASA should. No. So,